Welcome to the 11th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will cover the concept of acceleration. In the last video, we discussed speed and velocity, and now it's time to talk about how we can describe the change in these quantities. As we discussed, speed is a scalar, but velocity is a vector quantity, so it can change in two different ways. First, its magnitude can change. So, for example, a car can be accelerating. Second, its direction can also change. For example, when you're driving around a curve on the road. You might keep the same speed, but the direction of your velocity will change as you swerve around the curve. In physics, we describe the change in velocity with acceleration. As the velocity is a vector, acceleration will be a vector as well, which makes total sense. The direction of acceleration is important as well. In this video, we will only consider linear motion, but even in this simple case, there are two different cases. First, if the velocity and the acceleration vectors point in the same direction, the object is accelerating, so its speed will increase over time. Second, if the velocity and the acceleration point in the opposite direction, the object is decelerating, so its speed will decrease over time. We can calculate the acceleration using the following formula. A equals delta v over delta t. So the average acceleration is the change in velocity over the time elapsed. What will be the unit of the acceleration? The unit of velocity is meter per second, and we have to divide it by the unit of time, which is seconds. So the unit of acceleration will be meter per second divided by second, so meter per second squared. It is very important to have a clear distinction between velocity and acceleration. To have a clearer picture, let's discuss these four cases. First, what if a car is just starting? Its velocity is zero, but the speed will increase, so the acceleration is positive. Second, the car goes with uniform velocity. In this case, the velocity is some positive value, but as it does not change, the acceleration is zero. Third, the car is braking. In this case, the velocity is some positive value, but the speed is decreasing, so the acceleration must be negative. And finally, the car is stopping. It still has some very low speed, but it is decreasing, so the acceleration is negative. Now, let's see how we use the formula for acceleration in a concrete example. A cyclist increases the speed from 2 meters per second to 6 meters per second in 4 seconds. What is the acceleration? So the formula was that the acceleration is the change in velocity over the time elapsed. In this case, the direction of the velocity does not change, so we can simply subtract the initial speed, 2 meters per second, from the final speed, 6 meters per second. So this difference will be 4 meters per second, and we have to divide this by the time, which was 4 seconds. So the final result is that the acceleration is 1 meter per second squared. Finally, let's discuss a couple of questions to test what you just learned. First, a car is moving to the east but slowing down. What is the sign of the acceleration? The answer is that the acceleration is negative because the speed is decreasing. Second question. A cyclist goes faster and faster downhill. What is the sign of the acceleration? The answer is positive, because the speed is increasing. Third question. Can an object have acceleration if its speed is constant? This is a tricky one, but you have to remember that the acceleration is the change in velocity over time, not the change in speed over time. So even if the speed stays the same, the object can have an acceleration if the direction of the velocity vector changes. For example, when a car swerves around a curve in the road. Thank you for your attention, and see you in the next video.